Hi guys, welcome to another video of Physics 2. In this case, I'm going to explain the topic of horizontal throw. Okay, so let's begin and let's make the drawing. Okay. So we got a person that is here. Oops, I'm going to change the color. Oops. And this person, let's say that is standing at the edge of a cliff. And this person is going to throw an object horizontally. Okay, so that means okay, horizontally I'm talking about this one, just like this. Okay, so the object will go something like this. The motion of the object or the path or the trajectory will be something like this until, let's say, it hits that object, hits the ground, okay, or crash the ground, just like this. Okay, so if you see, well, this person throw the object in horizontal motion, but the object is going down too. So this is the beginning, this is the first topic about motion in two dimensions. Okay, I repeat, this is the first example of motion in two dimensions. The previous examples that we were studying, free fall, vertical throw upwards, or vertical throw downwards, so they are examples of motion in only one dimension. So this is the first topic about motion in two dimensions, and what I'm gonna do, I'm going to analyze this motion in two dimensions, the horizontal dimension and also the vertical dimension. But if you see, well, this object is not going up, okay, and that is because of the action of the gravity. Okay, so let's analyze this object. Okay, so here, for example, if we are going to analyze this object, I need to analyze in two dimensions. So the first thing, I'm going to analyze it in x. So this is the beginning of the motion, so to me this will be initial position. Okay, and here is the final, that's the end of the motion, so that's final position. Okay, now one important thing is that final position, you can find it also like total distance, or only distance, okay, or displacement. Okay, displacement, and also you can find it in the books or other videos as range. And if you find it as range, okay, so the letter will be R. Okay, but of course it is the same. Okay, it is the same thing that we are going to find. So if this is the initial of the motion, beginning of the motion, this is initial position, well, also I'm gonna have initial velocity in x, and this will be final velocity in x. Okay, and I'm gonna have acceleration in x. Okay, I'm gonna write, this is the time, and also I have acceleration in x, and the time is the time that takes the object to go from that place to here. Okay, that's the time. That's the data. For example, that's the data in the x-axis or the horizontal dimension. Now let's analyze the vertical dimension. So this is the beginning of the motion. Okay, so this will be the initial position, and that will be the height. Okay, the height at which the object is being thrown. Also, I got, at this point, I got initial velocity in y. Okay, and the end, this is the end of the motion. Okay, I continue. I do this. Okay, so at that point, I got final position in y. And the final position in y, because we are talking about ground level, it will be 0 meters. At that point, I'm going to have final velocity in y, okay? In this case, it's going to be negative. Why is that? Because the object goes down. I want you to remember the reference system. That is very, very important, and that is something that if you have noticed, uh, everything that goes up is positive and everything that goes down is negative. I hope you remember that, okay? And also, in this case, well, I got acceleration in y, and I'm going to write it in red because that is something that is going to be the same for every problem. So acceleration in y equals the value of the gravity, that is minus 9.8 meters per second square. And I also got the time that takes the object to go from that height to the ground level. Okay, so there is something very important that I want you to notice. If you see, all the variables have the index or the subindex y, and the variables in here, they got x, except for time. Okay, if you see, I just wrote time, but I didn't write time y or time x. That's because the time will be the same for both dimensions. Okay, and well, that is something that I'm going to write over here in red color. Okay, time is the same for both dimensions or both axes, both dimensions. Yes, because it's not possible that we get a time, so the object is going to reach the maximum or the total distance in at one time, and it's going to hit the ground at different time. If that happens, well, that will look strange and weird, and I don't know, that is not physically possible, or I don't know. It doesn't respect the laws of the mechanics. Okay, now what I'm going to do, I'm going to make the analysis, but with the formulas. Okay, so we're talking about two dimensions, so the first analysis that I'm going to do is the x-axis. Yes, x-axis. So the first thing that I'm going to do, I'm going to write the equations. Acceleration in x equals final velocity in x minus initial velocity in x over time. That is the first equation, and the other equation will be final position equals initial position. Oh, sorry. We are talking about x. Final position equals initial position plus the initial velocity in x that multiplies the time plus the acceleration in x that multiplies the time square over 2. Okay, so in red, I'm gonna write everything that is going to be the same for every problem. So acceleration in x is the same if in every problem. So this one is 0 meters per second square. If I don't have acceleration, that means that the velocity in x is not going to change, because remember, acceleration is the change in velocity. So that means that the velocity in x all the way is going to be exactly the same because there is no change in velocity. So for example, imagine the object at this point. Okay, the object is here. So remember, I'm gonna have, at that point, I'm gonna have a velocity in x, and also I'm gonna have a velocity in y. Okay, those are the two vectors that I'm gonna have all the time, or the two rectangular components that I'm gonna have all the time. So if that's the case, well, that means that the initial velocity in x equals the final velocity in x. Okay, so that means that there is no difference if I write initial or final. They are the same, so I'm just gonna write velocity in x. Okay, so that's the only thing that I'm going to write. And the other note is that the initial position in x most of the times is 0 meters. And when I'm talking about most of the times, I'm talking about the problems that we're going to see and then 100% of the times the initial position is 0. Well, let's say 99% of the times. So that being said, okay, let's cancel everything that is going to be 0. So if the acceleration is x is going to be 0, I can cancel this whole equation. And the initial position I'm going to cancel because that's 0, and acceleration is also 0. So the only equation that I'm going to use is gonna be x equals the velocity in x that multiplies the time. If you see, I didn't write final position in x because I can find the position in x at any given time. I can find it here, or here, or here, or over here. Okay, so this equation is to to know the position at any given time, and I'm talking at the position in x. So this is going to be the first equation that I'm going to write. Okay, and if you want to write position or displacement or distance or range, position at any given time. Okay, I hope I made myself clear. Okay, you can find the position. You just find the velocity in x, and you just substitute the value of the time that you want to know. Could be 1 second, 2 seconds, 3 seconds, 0.5 seconds, any number that you want to substitute here. By doing that, you are going to find the position in x. Okay, now let's continue with the y-axis. Let's make the separation over here. Okay, so y-axis. Y-axis. So let's write the equations. The first equation is acceleration in y equals final velocity in y minus the initial velocity in y over time. Okay, and final position equals initial position plus initial velocity in y that multiplies the time plus the acceleration in y that multiplies the time square over 2. Okay, so in this case the final position in y is the ground level, so to me it's going to be 0 meters. Okay, also the acceleration in y is the value of the gravity, that is minus 9.8 meters per second square. Okay, and if I go again to the drawing over here, okay, this person over here is going to throw the object horizontally, not vertically. horizontally. So that means that all the velocity is going to go to the x-axis. Okay, what about the y-axis? Okay, the y-axis, I'm gonna treat the y-axis as free fall. If that's the case, the initial velocity in y will be 0 meters per second, because this person is throwing the object horizontally. Okay, is not doing it by throwing the object vertically. Okay, so the angle, let's say that the angle is 0 degrees. I hope you remember the Cartesian plane. This is 0 degrees, this is 90 degrees, this is 270, and this is 180. Horizontal throw, that means that the person is going to throw the object at 0 degrees or 180 degrees. And that is the case that is if this person throws the object to the left. So well, remember, if we're working with the reference system, everything that goes to the left, well, in our case, will be negative. That's why we are always supposing that our problems begin from left to right, okay? So the y-axis, I'm gonna write over here that is going to be treated as free fall, and that is a topic that we already saw. Okay, free fall. So I'm gonna write here that initial velocity in y is 0 meters per second. Okay, if that's the case, okay, I'm gonna cancel this one. So acceleration in y equals final velocity in y over time. So from this equation, I'm going to find velocity in y. So it's going to be, I'm gonna do it over here. Velocity in y equals acceleration in y that multiplies the time. Even if you see, I just get rid of final velocity in y, because this is an equation. With this equation, I can find the velocity in y at any given time. Just remember, just as free fall, the initial velocity is going to be 0, okay? So the acceleration, the gravity is going to make that the velocity changes. That is the acceleration, a change in velocity. So that means that at 0 second, my velocity will be 0. At the first second, it's going to be minus 9.8. At the second, the velocity is going to be this time 2. The only thing that I need to do is going to substitute the value of time, okay? And the value of the acceleration will be always the same, okay? So I'm gonna circle this one, and you can write that this is vertical velocity at any given time. Vertical velocity, because sometimes in the problems they're going to ask you for the vertical velocity or the horizontal velocity at any given time. Okay, now let's go here and let's cancel everything that is going to be 0. So final position is going to be 0. Initial velocity is going to be 0. And that's it. So from that equation, I'm going to find initial position equals the negative or minus acceleration in y that multiplies the time squared over 2. Okay, that's initial position. Okay, just remember that initial position is the height. Okay, initial position is the height. Okay, so every time, for example, when I substitute, when I begin by doing values, okay, let's say that, what about the first second? Okay, the height at the first second. Okay, so let me open my calculator. It's over here. Just give me a moment. Okay, oops. Okay, so at the first second, what was the height at the first second? So negative minus 9.8 meters per second. That multiplies 1 second over 2. Okay. Oops, I made a mistake. Sorry. It's negative times negative 9.8, and that multiplies the time. In this case, it's going to be 1 second raised to the square, and everything will be divided over 2. Okay, I can do this over 2. So if you see, it's 4.9 meters. Okay, but let's say that the height, okay, the total height, let's say that the height is 20 meters. Okay, so, and if I use this formula, it's going to tell me that at the first second the height is 4.9 meters. So that is not possible. I hope you understand this, that is not possible, because the height is measured from the bottom to the top. Okay, from the bottom to the top. So 4.9 meters. Okay, and the height, for example, and the motion that I'm doing is that I'm here, I'm above. Okay, I'm at the top. So this object is going to be falling. So this 4.9 is not the height, is the distance that the object travel. Okay, it travel 4.9 meters, just like this. This distance is 4.9 meters. Okay, but that is not the height. Okay, if they're asking you the height at the first second, what you need to do is to subtract the total height minus the height that you found. So that is going to be the height at that point. Okay, so I hope I make myself clear, because that is like a trick with this equation. Okay, so I'm gonna circle this equation. Okay, this is the initial position, yes, but you can use that equation also to find the distance travel. Vertical distance travel at any given time. Okay, at any given time, the vertical distance travel. Okay, I hope, but don't worry, once we are doing the problems, I hope this is already answered. Okay, now what about the time? Well, time is going to be minus 2 times the initial position, that will be the maximum height, over the acceleration in y, and also this will be the square root. Okay, so I'm gonna circle this equation over here. With this equation, I'm going to find the time that takes the object to travel this whole vertical distance. Okay, I repeat, this whole vertical distance. What is the time that took the object to reach the ground? Okay, with that equation, I'm going to find it. Okay, and you can write it. Time that takes to hit the ground. The ground. Okay, that's it. But now, well, before I continue, now I got the equations that I'm going to use. I got the equation for the x-axis and the 3 equations for the y-axis. So that means that I'm not gonna use this equation again, because imagine, I'm not going, the problem is going to become so long, because I need to write the equation, and then I need to cancel everything, and then I need to uh, get new equations. So the next time we do problems about this topic, I'm only going to write these 4 equations. But we're not done yet. I told you that every time, every instant, this object is going to have 2 vectors, the vector in x and the vector in y, or I can call them rectangular components. Just as the first videos that we watched, if you don't remember, well, I invite you to watch them about vectors, and remember that if these are the rectangular components, okay, I'm gonna have a resultant vector or a vector in a polar form, and this is going to be that vector. Okay, so every vector has 2 rectangular components, and also I'm gonna have an angle. This is going to be the angle. Well, remember that the angles are measured from 0 degrees from the origin, so that angle will be this one. That's the angle that I want. But remember that in the problems we were looking for, well, the angle that we got was this one. Okay, now every point is going to have the 2 rectangular components and the resultant vector. So for example, at the end over here, I'm going to have the resultant vector. Also, I'm going to have the velocity in x, and of course the velocity in y. Okay, that's what I'm going to have. So I'm going to add two other equations, but those are equations that you were supposed to remember. And the first equation is to find the resultant vector equals the velocity in x raised to the square plus the velocity in y raised to the square. Okay, remember that the vector could be written in 2 forms: the rectangular components and using the polar form. Remember that in polar form, I'm going to write it here, in polar form, we got magnitude and direction, and the direction is an angle, and that angle goes from 0 to 360 degrees, or 0 to 359.99999. Okay, so by doing this equation, okay, you're gonna find the magnitude, and also, well, I need the direction. So remember that the direction is found with this equation, that is, the angle equals the tangent inverse of the vertical component of the velocity over the horizontal component of the velocity. Okay, but remember that I need to find the angle from measure from 0 degrees. So if you want to know what to do, well, you need to know in which quadrant you are. The quadrant, I'm talking about the quadrant of the Cartesian plane. Okay, I hope you remember that. I'm gonna draw it again. So this is the first quadrant, second quadrant, third quadrant, and fourth quadrant. Okay, so if I see this drawing over here, well, I see that the resultant vector is going to be in the fourth quadrant. This is because I'm assuming that the object is being thrown from left to right. If you want to change that configuration, and if you want to do it from right to left, okay, in that case, the resultant vector will be on the third quadrant. And okay, so if I find the angle, I'm going to use the vertical component. The vertical component is going to be negative, so that means that the angle is going to be negative. So I need to find this one, the resultant angle, or the angle that is measured from 0 degrees. So by doing that, I need to add 360 degrees. Okay, I hope you remember that. So the total angle equals 360 degrees minus the angle of the fourth quadrant. So this angle that I found, so for example, I'm gonna, I don't know, I'm gonna make an example. Shift tangent of, remember that it's going to be negative minus 20 over, I don't know, 14. Let's say, let's see what happens. Boom. Okay, this is the angle, minus 55. So the only thing that I'm going to do is that I'm going to add 360 degrees, and that will be the total angle, 304.9920 degrees. Okay, so that is because it is very important that you identify that we are in the fourth quadrant. Depending on the quadrant, that's the equation that we're going to find, and that information is also in the vectors video that I just made, and I'm gonna put the suggestion over here. Okay, so this is the whole explanation of the horizontal throw. Okay, maybe you see that there is a lot, but believe me, once we are doing the problems, we're just gonna have 4 equations, and maybe well, depending on the problem, because if the problem says, hey, I want to know the velocity, the final velocity. Okay, so the final velocity, if the problem doesn't say find the final velocity in x, or the final velocity in y, or the vertical velocity, the final vertical velocity, okay, so in that case I'm gonna find bx or by. But if the problem does not mention that, I need to find the rectangle, the total vector, the resultant vector. So I need to use these two equations, because if I need to find the resultant vector, I also need to find, well, I need to find the magnitude and also the angle. Okay, but we're gonna see that in the next video, and I hope I see you there. So take care, guys. Bye bye.